Hello, everyone, and welcome to Talk Nerdy. Today is Monday, April 8th, 2024, and I'm the host of the show, Cara Santa Maria. Happy North American Eclipse Day, everyone. And of course, I'm recording this in advance, so I have no idea if you are experiencing the awe and wonder of the great North American eclipse, or if sadly the clouds have overtaken. But I'm hoping for the absolute best. I'm time traveling a bit, but hopefully I'm in Texas and I'm crying my eyes out at the beauty of it all. We shall see. I'll give you an update next week. But of course, as always, before we dive into this week's episode, I do want to thank those of you who make Talk Nerdy possible. Remember, Talk Nerdyism will always be 100% free to download, and that's because I rely on the support of listeners just like you. Those listeners this week include Daniel Lang, David J.E. Smith, Mary Neva, Brian Holden, David Compton, Gabrielle F. Jaramillo, Joe Wilkinson, Pasquale Gelati, Riva Keith, Ulrika Hageman, and so many more. If you'd like to pledge your support on an episodic basis, all you've got to do is visit patreon.com/talknerdy. All right, so this week I had the opportunity to chat with Dr. Juli Berwald. So she is an ocean scientist. She actually earned her PhD in ocean science from the University of Southern California. She's also the author of a science textbook and the editor as well. She also wrote an incredible book called Spineless about jellyfish. And she has a new book called Life on the Rocks, Building a Future for Coral Reefs, which was or is an LA Book Times finalist and a Nautilus Book Award winner. She is also the co-founder and president of Telecoral, and we're going to talk a little bit more about that sort of towards the end of the show. But we're going to talk about all things coral reefs. This week, I don't think we had even the chance to dive into jellyfish at all. So I think we're going to have her back on the show to get a little bit more into some other aspects of ocean science. But there was so much to unpack when it comes to coral reefs that's what we spent the hour on. So much to get to. I don't want to waste any more time. Without any further ado, here she is, Dr. Juli Berwald. Juli, thank you so much for joining me today.
It's terrific to be here, Cara. Thanks for having me.
Awesome. So we are going to be talking about your new book, Life on the Rocks, but also your older book, Spineless, and all things, maybe coral, maybe jellyfish, just ocean things, and you personally, a lot of your previous work, the work that you're up to now. So maybe before we get into sort of your transition into just like science writing generally, and let's get into your interest in the ocean a little bit, because you are a scientist yourself. What is a PhD in ocean science? Is it a multidisciplinary PhD? That feels very broad to me.
Yeah, it really is actually. I always wanted to study corals. I discovered the ocean in college. My junior year, I was on a study abroad program in Israel, and I had grown up in Missouri. And so we never went to the ocean. I mean,
it's a bit landlocked, right?
Yeah, it's pretty far. I never went to the ocean, but I had never gone diving or stuck my head in the water or anything like that. And then my junior year, I went to Israel and I was really miserable on my program. Like, it was a terrible fit for me. I'm a pretty friendly person, but I wasn't really making great friends. It was awkward. And there was a sign on the wall and it was like, marine ecology course over winter break, sign up here. And so I just did, because I was like, I just need to change something because I'm not happy. And we got on these buses and we went down to the Red Sea, and we got off the bus and I was like, where am I? Because I never had seen these, like, it's a crazy scene. It's like red mountains and blue ocean. And it was such a different landscape than I'd ever been in. And then the teachers in the class were like, here, put on this mask, put on the snorkel, put on these fins, go in the water. And I'm like, I don't know how. And they're like, go do it. Don't ask questions. And so I just threw my head in the water. And I was like, where am I? Like, this world is not like anything I've ever seen before. And it was, architectural. There was all this vibrancy. There were so many colors. It was, it was revelatory in a way I couldn't believe existed on the planet with us. And I also kind of realized that this incredibly rich ecosystem that was so foreign to me was all animal driven. Like this wasn't trees in a forest. This was animals creating the structure. And that just kind of captivated me. And so anyway, got out of the water. I'm like, I'm going to be a marine biologist. And then I got back to college and they were like, you can be a marine biologist, but you have to transfer schools because we don't have that degree. And you're like way too far along to switch your major. So anyway, I um I eventually did get into grad school to study oceanography. I'm getting back to the question. I eventually did get into grad school to study oceanography, but not corals. And that was, like how life is. Sometimes you have to walk through the door that's open, even if you wish the door kind of led to a different hallway. And so,
Right. But even if something's kind of semi-related, you're like,
yeah,
I'm gonna learn all the things.
exactly. And my undergrad had been in math. And so I got into grad school to work on like ecological models of the ocean initially. And so you're right. Like I did take a lot of classes that were kind of straddling both geology and biology, because oceanography is, well, like biological oceanography is the study of the biology in the ocean, where the ocean is the lead player. Marine biology is to study animals that live in the ocean, where the animals are the lead player. So there's kind of like an emphasis there. So I was more biological oceanography. And what my dissertation ended up being on was satellite imagery of the ocean, where I was working on the algorithms that we could use with satellite imagery to predict how much photosynthesis was going on in the ocean. So it was it was back in the 90s, and we already knew that like climate change was affecting our planet, and we knew that we really needed to understand the carbon dioxide budgets of our planet, but we didn't really know what the ocean's role in that was. We knew there was a lot of phytoplankton. Those are the teeny little microscopic single-celled plants that live in the ocean. We knew there were a lot of phytoplankton, that they did a lot of photosynthesis, which sucks up carbon dioxide, just like trees use it, suck up carbon dioxide, mix it with water and get oxygen and sugar. But we didn't really know the patterns very well of photosynthesis in the ocean until we had these satellites that just came out when I went to grad school that sort of like mapped the color of the ocean. And from the color of the ocean, like how green it was, we could say, oh, there's this much chlorophyll, and that probably means there's this much photosynthesis. And so we were able to find that the ocean's really like complicated and beautiful swirly patterns of photosynthesis, and ultimately calculate that about a third of the carbon dioxide that we've put in the atmosphere from burning fossil fuels has been taken up by the ocean through photosynthesis. So that was my dissertation, and it was it was across a few different departments. Yeah, yeah.
I love it. And so when you first like dipped your toes in, you're telling us about that experience in Israel. And, since then throughout your research and continuing throughout, your writing, did it scare you at all? Like for me, I find the ocean interesting, but every time I've never dived, and every time I snorkel, I'm a little bit overwhelmed and scared by it.
Yeah,
You don't have that experience, do you?
it's so weird. It's like literally the opposite for me. And I I go into this a little bit on Life on the Rocks because my daughter well, my books are kind of like science memoir mashups, and we can talk about like why I've chosen to do that if you want to. But my daughter becomes a character in Life on the Rocks. And she was going through severe struggles with mental illness at the time I was writing the book. And she had like very high anxiety, and she learned to dive. And what I sort of came to understand about it is that diving does this thing. It definitely does it to me, and I saw it do it to her. And I've heard, and I've people have written about this, where it like soothes your nervous system in a way, because when you're underwater, um, it's like basically what they tell you to do during a panic attack. It's like the ocean does all that to you, so you're like swaddled, like there's literal pressure on your body,
Yeah. Yeah.
and that is like so soothing. And then if you're wearing a wetsuit, like double that kind of like swaddling feeling. And then when you're underwater, you have to be very intentional about your breath. So you're like inhale, exhale, inhale, exhale. You have to focus on it. And also when we have a panic attack, like that breathing is so important for calming us down. And then the mask actually focuses your attention. And one thing to do when you have a panic attack is like look at something and touch base with it. And so all of those things kind of happen just naturally when I'm in the water. And I think that it like, I don't know, for me, it like is a bath to my to my nervous system.
I could see that. Yeah, it could be very, very calming. I
But I'm
think for me,
yeah.
it's less about the behavioral aspect of it, and it's more about the existential aspect of it, because I don't have anxiety. I'm actually the opposite. So so I'm a psychologist, right? And like these are all of the behavioral things that you 100% do when you're experiencing panic. I don't experience panic. I help people do these things when they're experiencing panic. But for me, when I have attempted a lot of snorkeling or just a lot of experience, I've even done breath hold training before. But when I've tried to do all those kinds of things, it's not that it induces panic for me necessarily, but I existentially don't enjoy being in situations where I know that not I didn't evolve to be able to live.
Yeah, no, I
Does that
get
make
that.
sense?
Yeah, I get that. I totally
Yeah.
I do, because I think I feel that same way when I fly.
Yeah, okay, that
Like,
makes
what
sense.
are we doing
Yeah.
up here? Like
Yeah,
this feels wrong.
right.
So I completely understand that idea for sure.
Mm.
Um,
I also think I have a mild phobia. Maybe it's not phobia is not fair to say because people have legitimate phobias and I don't have this, but I do think I have like an ick factor around swarms. Anything that swarms is like icky to me. Like, and so it's funny because most people have these like transcendent experiences around like big schools of fish. And whenever I have snorkeled in like really beautiful places and very large schools of fish start to pass by, I'm like, oh God, oh God, oh God, oh God, oh God.
I wonder
And I want to get past that
That's
because
so
it's
I've like,
beautiful.
never heard anyone say that before, and I think it's really fascinating, and I wonder if it's a sense of, like, I'm part of the prey here,
Maybe it
like
could be.
yeah. Yeah.
Yeah, because it's not like it's funny because it's not like when it's a large like, if I see a shark even, I don't have that response. Like, clearly these fish
Yeah,
are not going to hurt me, but there's something about a lot of something.
that's so fascinating. I have really never heard anyone say that, but
That's so
I
funny.
think it's really interesting.
And of course, I've never had that experience around coral, and this is something I wanted to bring up, not from a personal perspective, but because you said you had this experience when you did that first, dive, or maybe it wasn't a dive, but
It was
that first time
yeah.
okay, but that first time when you were in the water, you had that experience where you realized, like, this is not a forest, these aren't trees, these are animals, and I'm not sure some people might logically understand that, or maybe they don't know that, but corals are animals, and obviously they have features that are animal like they fit squarely in the animal kingdom, but there are so many things about them that are not like like ostensibly animalistic to us. They feel they feel plant-like to us, right? There's something about a reef that feels like a forest.
That's right. It does. And I mean, they're, they're cousins, the anemones. Anemones are
Mm-hmm.
basically corals without skeletons.
Mm.
They're called anthozoans, which are like plant animals. So
Oh, really? Is that what the word means?
yeah, what? Yeah,
Is that what the
yeah,
Oh.
and is like it translates as plant animal from the
Oh, I love that.
Greek or Latin or whatever. So yeah, I mean, they are like, they have almost like their tentacles are almost like petals looking, and they just have this little mouth in the middle that looks kind of like the center of a flower. And yeah, and they're plant themselves. Like they stay in one place their whole life, and they grow, well, for the corals, they actually like grow hard structures just like trees grow trunks. So you're right. They have a lot of things that make them plant-like. They're the base of ecosystems as well. And yeah, like like and like forests and jungles, um they're super high. They create the space for super high biodiversity. So a quarter of all marine animals, that's something like 860,000 species, depend on coral reefs. And yeah, and they take up less than 1% of the ocean's area. So they have like an outsized impact on our planet and its biodiversity. And just like jungles do. So yeah, I mean, they have a lot of similarities. But it's like, to me, it just kind of turns things on its head that these are animals, except that they're kind of solar powered animals. And
Okay, which is very plant-like in a
which is
way.
very plant-like. And so the kind of magic of corals is, um, they live, like, if you notice, they live in tropical places, and they live kind of close to the surface. And the reason for all of that is because that's where the most sunshine is on our planet, if you're a marine animal. And the reason that they need that is because in their tissues, they have a symbiosis with like these algae, these dinoflagellates that are called, well, they used to be called zooxanthellae, and now they're called Symbiodinium or Symbiodinaceae. And those parts of the ocean, the tropical parts of the ocean, are like oceanographically like deserts. There's not very many nutrients there. There's not like a lot of fertilizer if you want to compare it to land. And so it's really like, it was Darwin's paradox. Like, why are these super rich marine environments in these places where there's not enough nutrients really for life to exist in this bounty? And the answer comes from the symbiosis. So the algae has gone into the coral's tissues, and it lives inside there. And the algae photosynthesizes like algae do, and like phytoplankton, like the ones I studied in grad school do. So carbon dioxide, water, you get oxygen, sugar. So that sugar, oh, and light, carbon dioxide, light, and water, and you get sugar and oxygen. So the sugar, the algae feeds 90% of the sugar it makes directly to the coral. And that's like a boatload of energy in these like deserty parts of the ocean. And the coral uses all that energy to make its skeleton and these limestone reefs that are, you can see from space, and that then support all this life. So it's this incredible symbiosis that allows that to happen. And the coral gives the algae its like waste products, which are nitrogen, and it also supplies carbon dioxide to the algae. So they're super tightly bound together. So they're not like, those nutrients aren't like diluted out in the ocean for the algae to have to go find. The coral actually controls the algae through supplying it nitrogen, which is the most or the least available nutrient in those parts of the ocean.
I see. And then so there's that super tight symbiosis, but
Yeah.
then there are like looser symbioses going on with like like a ton of different species, right? Like
Yeah.
there's tons of things that are living, on the reef, in the reef, around the reef. It's like a whole ecosystem.
Yeah, well, 860,000 species. So
Yeah.
you have and everyone's kind of living tightly together. So yeah, I mean, there's all kinds of there's like the SCOBY and the shrimp that like live together in the same hole. There's all kinds of feeder stations, cleaning stations. Yeah, like little wrasses will go in other fish's teeth and clean them out. I mean, there's all kinds of, there's little brittle stars, which are kind of like sea stars that live wrapped around sea fans. There's just all kinds of interactions on the coral reef. Yeah.
And then, I think we hear the term bleaching a lot, and that has become like the sort of the sort of hallmark for like what climate change is doing to corals, but it's more complicated than that, right? It's not like, oh, they're losing pigment or something like that. What is actually happening in the oceans with regard to pH, with regard to nutrition that is causing corals to die in mass?
Yeah. So it's like a perfect transition from what we were just talking about. So this tight symbiosis between the coral and the algae, it was first identified. Well, I guess it was studied a lot. There's a good little thing in my book I write about. I was wondering, like, when was the first bleaching noticed? And it
Right.
was actually in 1919 on the Great Barrier Reef.
Oh, okay.
And they noticed it during low tide, when some of the coral were like close to the surface of the ocean, and like they would bleach when the water got really hot during low tide.
Okay, so it
And
was kind of related to temperature, at least that's what they
yeah,
saw. Okay.
yeah. And the guy who first noticed it, he was like this English guy, and he's like, it shouldn't be too hard to figure out what this bleaching is all about. But here we are, like 100 years later, and we really don't know what causes bleaching. I mean, we know what it is. So what it is when the temperature rises by a couple degrees for like 4 weeks, for a month or so, um, the algae will leave the coral. And so it is actually that. So the algae, the color of coral is due to the algae. And when the algae leave, the coral's tissue is actually clear. Um, and so you're seeing through the tissue to the white skeleton, limestone skeleton that they make. And so that's why they look bleached. You're seeing their bones underneath. And we don't know why the algae leaves the coral animal. We don't know if So, like, in order for something foreign to be in our tissues as an animal, our immune system has to allow that to happen.
Right, it has to not attack it.
It has to not
Mm,
attack it. So, the coral's immune system must be dialed down in order to allow the symbiosis to occur,
mhm.
or the algae is somehow tricking the immune system into thinking it's a coral cell to
Right,
not let it.
okay.
So,
Mhm,
but we don't know which of those things are happening.
mhm.
Um, and so then when the temperature increases, the coral starts to, you can see stress responses in the coral animal. And so we don't know if the coral's immune system is becoming like more serious, or, just like, okay, I'm going to ramp up my immune system. Like, I'm getting stressed. I don't like this temperature. I'm going to just like be more diligent about allowing foreigners in my body. Like, maybe that's the source of the problem. And and then it kicks, it's like, this thing that I sort of had ignored for a while, maybe that's causing me stress. I'm going to kick it out. Or if the algae is like, hey, my nitrogen supply is not happening the way it used to,
Mhm.
like things
Yeah,
aren't so good anymore, I'm going to reveal myself to the coral's immune system and get kicked out. So
gotcha.
we don't know the trigger, but that's what bleaching is. And and so with the algae gone, the coral, its sugar supply is gone. Um,
Oh, so it can't eat.
it can eat, but it can eat, but it's not used to having to eat very much. And there's
Okay,
not a lot of food in these oceans because they're
okay.
nutrient poor. So its like major nutrient supply is gone and it starves to death. And that's what happens if during bleaching. And so
Gotcha.
if the water cools and the coral can reestablish the symbiosis, the coral and algae can reestablish their symbiosis, and it can survive. But if the water doesn't cool, then the coral just starves to death.
Yeah. Yeah. Oof. Poor
Yeah.
coral.
Yeah. And then like in regard to the other things like pH, um,
Mhm. And like, yeah, right? Because isn't there like it's something about acid, or am I thinking of like
yeah.
creatures with shells in the ocean?
Yeah.
That's like a thing, right?
Well, so it's really interesting. As we've added more carbon dioxide to the atmosphere, um, that carbon dioxide mixes with water and forms a weak acid, carbonic acid. And that has pushed the pH of the ocean, which was around 8.2, like when I was in grad school, down to 8.1 now. And 7 is neutral. So the ocean is always a little bit basic, but it's less basic than it was. So you don't want to say the ocean's acidified because it's technically not. But anyway,
Right. It's just
yeah,
slightly less basic. Right. Okay.
more
Yeah.
acidic. It's
You're
more
right. More acidic. Okay.
And so when we realized that this was like having an actual measurable effect on the ocean, and this was probably around 15 years ago, people were like, oh my God, things with shells aren't going to be able to make their shells. Everything's going to dissolve. And
Yeah, I remember that.
yeah, and it was like a huge push in research. It turns out that for most animals, that as long as they're alive, they're pretty good at handling these changes in pH. Um, they are pretty good at controlling pH around their bodies. The corals are. Um, some of the animals are not. There's these things called sea butterflies, which are like little mollusks that um, they're like little flying snails. They're so beautiful. Um, and they have been particularly affected. But a lot of animals that we thought were going to have trouble have turned out to be like we've seen this show before. We've seen the pH of the ocean change. So the corals are turning out to kind of to be that way. They don't seem to care as much as we thought they might. And but that only goes for when they're living. Like once they die, um, they don't have the ability to control the pH around their bodies, and then we do start to see the coral reefs erode faster. Um, and that's happening in the Caribbean.
Okay. Okay. And that's not good either. Yeah, pretty bad. And so what do you think are the major wh- maybe I should say like what is your um forecast for coral reefs now? Like what do you think the future looks like for them?
Um, it's it's not a rosy future. um, yeah, it's we are putting the corals in significant stress by not addressing climate change. I mean, the IPCC, the International Panel on Climate Change, their predictions are super dire. It's like 99% chance that 99% of all corals will be dead by 2050.
Really? And so what does that mean then for the planet? You know what I mean? Like what is the role that corals have ecologically?
I mean, Kara, I really like it hurt it it's so hard for me to even go there. I like
Right.
feel like pained, but yeah, like I said, 860,000 species. Suddenly
Mhm.
this 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 habitat that they rely on for their some part of their life cycle is no longer there. And so did they all go extinct too? I don't know. Um, it's just it's terrible to think about, and it would mean a collapse of fisheries. A lot of fishery fish use the coral reefs for their nurseries. um I yeah I I don't know if we can really conceive of what it would mean. for that to happen. I mean, and the good news is like, we don't know for sure. And it turns out corals have a lot of variability. So we see that there's always survivors in bleaching events. Um, there's always individuals that seem to somehow weather the storm, but whether they can reproduce fast enough to spread those genes throughout a population is unclear. And coral reproduce slowly and they grow slowly. And so there's a lot of problems to imagine how that could happen. But yeah, I mean, currently the Great Barrier Reef, which is the largest coral reef on the planet, um, it's like it's 3,000 smaller reefs, and it's like I think 1,400 miles long. So if you picked it up in like it's the size of Italy, basically, a reef the size of Italy. So massive, massive structure, all built by these little coral animals. Um, it's undergoing a massive, very serious bleaching right now because we're in this El Nino and it's the summer there. So it's been hit really hard. But what they're seeing, I think they're calling this the 5th or 6th mass bleaching of the Great Barrier Reef. And what they're seeing is there is recovery, these sort of quote unquote weedy species that reproduce pretty well and grow pretty fast are coming in to take the place of the corals that die. So we're seeing some community structure shifts, but we're not seeing like total death. And it just, can those weedy species keep up with it or not?
And so those are animals, right? The weedy species.
Yeah, they're all animals, right?
And so I think that's an important point, right? And that's not to say, oh, it's fine. Just like swap it out. Like that's not how this works, right? That's not how ecology works. Like hopefully they can bear some of the burden or maybe hold some space while the corals maybe recover. But I we've seen these big pushes, and I'm interested in your take on them for like artificial corals, and I see this a lot in like dive communities where it's like, oh, we'll just drop a shopping cart in the water and then like shit'll grow on it and people will dive around it and it'll be great. But like, can you really just drop some cement blocks and hope that stuff grows on it? Like, it doesn't work that way, right?
Yeah, it's yeah, I've seen some really disastrous
Right.
coral, quote unquote, coral restorations
Because
because,
coral is an animal that's alive and cement is not.
well, not exactly. Like coral can grow on cement, and there are some places in the world,
Okay.
like off of, like in Indonesia, where
Hmm.
there's the most diversity of coral in the world, like 800 species of coral, and it
Wow.
hasn't been really hit yet by climate change as badly as other places.
Okay.
Coral will grow on cement,
Okay.
and you can do a restoration that's made out of cement.
So
The
you're really just providing scaffolding for the coral.
Yeah, well,
Okay.
yeah, the big issue in some parts of Indonesia anyway is this thing called blast fishing, where um, because of poverty and corruption and all kinds of things, the fishermen will throw a bomb in the water, and then it will explode, and then the gas bladders of fish will sort of get jangled around the fish float to the surface, and you can collect a lot of fish really fast. And it's yeah, by the way, we Americans probably taught them that when we were over there fighting World War I or two, sorry, World War II. But anyway,
So we exported this and now
yeah,
we're
we
like
exported the blast.
shitting all over it. Of
Yeah.
course. This feels like our way.
So the blast spots, like when I was in Indonesia, I saw one that was 30 years old, and the coral can't grow on that because the rubble just kind of rolls around, and coral make little larvae. They're like little swimming tic tacs. They're teeny little, like a rice grain with cilia all over it. And their job is to like swim down to the seafloor and find a place to plant themselves. and grow into a little baby coral. But when the rubble's rolling around, they get smashed before they can sort of establish colonies. So those blast zones don't recover. So yeah, if you go in and stabilize those, you can get a coral reef to grow back. And interestingly, like the Mars Candy Bar Company has done one of the best restorations I saw, and that was in Indonesia, where they created these things called reef stars, which are made out of rebar, and they coat them in sort of local sand and then network them together in these galaxies, and they tie little fragments of coral onto them using zip ties, and they, within a year and a half, you've got like this insanely beautiful reef again. And 3 years later, you can't even see. I mean, I wish I could show you pictures, but
I
you
know.
can't
That's one
see
thing
that.
that sucks about podcasts. Yeah.
But like but a completely healed scar, and stunning, just stunning. So yeah, I mean, in some places, these artificial structures are great, and they're solving a real problem, which is that the baby corals can't grow on rubble that's rolling around. In other places, the coral's job is always to outgrow algae. And I don't mean the little algae that live in their cells. I mean macroalgae, like mossy kind of stuff. And and so their job is always to outgrow them, that more mossy kind of seaweed. And but the seaweeds can grow a lot faster than the coral, because the coral has to build limestone, and that's just a slower process. And so you'll see some restorations where it's just like snotty moss fall on rocks or on cement or on junk shopping carts. Those are not successful restorations. And there's even some yeah, I've seen pictures of like someone trying to build a restoration on top of a perfectly healthy coral reef. And you're like, no. There's a huge funding mismatch for coral research and coral. And so if someone gets funding, they want to do something with it because they don't know when they're getting funding again. And and so those pipelines are really poorly built right now.
It's a
Yeah.
it's a problem, right? Like,
Yeah.
it's so hard to I mean, I get it, right? Like there's only so much money, and there are really dire things geopolitically and existentially that we as a species are facing. And it's hard to see some of these problems. We know them scientifically, but it is, I think, hard for sort of the every person to grasp the existential nature of species collapse or even of ecosystem collapse, and understand the downstream effects of something, especially something that's happening deep in the ocean. If you're somebody who never goes to those places, it's like, oh, that's happening over there.
Yeah, exactly. And I mean, I think that's a really nice segue for me to bring up, one of the themes in Life on the Rocks. I kind of mentioned that my daughter was struggling with mental illness while I was writing the book, and I didn't think I was going to include that story in the book. But what I realized is there was this incredible parallel, which was that people who struggle from mental illness, it's so often, not always, but it can be, and it wasn't her case, quite invisible. Um, you could look at her and just not know how sick she was. And it's like you said, it's the same with the coral reefs. Like it's just so invisible to us as terrestrial. We are terrestrial, right? So like you said, you feel like you shouldn't be in that place when you're snorkeling there. And so it is invisible to us. And there the kind of analogy goes further, because both of these things, our mental health and the coral reefs, are so foundational. And I saw with my daughter just like her life fell away when she was really sick. She isolated herself from friends. She dropped her community. She dropped her education. All of the things that you hope for your daughter or for really anybody. They fell apart, and the same for the coral reefs. Like, you asked me, what would it mean if the coral reefs go away? And I have a really hard time imagining what the end of this ecosystem that supports so many other species could be. And then, but I to not be like completely doom and gloom about it, like we we have the parallels also like extend to the solutions, which are that there are no silver bullets for solving mental illness, and that as a practicing therapist, like there's not one thing you can tell your patients, oh, this will be the answer. But we do have tools in our toolbox. We have behavioral therapies that we can try. We have some medicines we can try. We have a lot of things we can try. And similarly for the ocean, we do have tools to, like I talked about the restorations in Indonesia. People are also working on coral husbandry. They're working on reproduction strategies, planting new species in different places, and, solving climate change. Like, we have ideas, we know how to do it, really. We have alternative energy sources. But you have to have intentionality. You have to have focus. You have to know you're going to fail a bunch before you win. Like, these are hard problems, but we can work on it. And it's better if we work on these things collectively.
And
So,
it's better if we work on them sort of like it's better if we do them preventively. And
yeah,
holistically. Like, we don't want to be intervening with every mental health issue after something catastrophic, once somebody is homeless or after a suicide attempt. We
yeah,
want to be working on these things at the first indication that something's wrong.
right.
And
So
it's the same, obviously, with these climate change concerns.
exactly. And I mean, the corals are, yeah, I mean, they're way past the first indication that something's wrong,
Exactly. Yeah.
but they are a major, serious indication that something's wrong.
Hmm.
And so, if there's any way to create more urgency around climate change, let's create that.
I think it's such an important place, and I'm just curious, like, that's sort of an opening of the funnel, but I'm curious what some of the takeaways have been for you, especially, insofar as you're comfortable sharing with us what some of those big lessons that you've learned with your daughter, and some of the parallels that you've taken with your work, for example. Like, what are some of the, I guess I can say, the wins, some of the um uh promises, the optimisms that you've taken away from your work and from the what you've learned from your daughter and her journey.
Well, let me just say, my daughter ended up, yeah, I mean, in the book, I kind of tell the story of, I was invited to Australia to be part of this really cutting edge project, which was to try to cool the entire Great Barrier Reef. I mean, ultimately, this was a pilot project using something called geoengineering, which is, and the particular geoengineering is, well, let me just say, they wouldn't want me to say it's geoengineering. So let me erase
Okay. All right.
it is a tool that some people have considered part of the geoengineering tools, but what they want to do is just use it locally, so not to change the temperature of the planet, which would be geoengineering. But the idea is, marine clouds are less bright than land-based clouds because there are fewer little particles for the water droplets in clouds to form around over the ocean. There's no pollen, there's no dust. And so there's been some calculations that if you increase the brightness of marine clouds by adding little particles by like 5%, you can create a local cooling underneath those clouds of a couple degrees. And that's enough to keep the coral from bleaching. So the idea is to take sea salt. And so you take seawater and you aerosolize it and it drifts up to the clouds. The clouds get brighter. And when there's a heat wave coming, like to the Great Barrier Reef, like there was this year, you would add brightness to the clouds over the reef, and that would reflect solar radiation away back to outer space and cool underneath the clouds and keep the coral from bleaching. So it's called cloud brightening, marine cloud brightening. And so I was invited on the very first marine cloud brightening pilot study. And I was so excited. And my daughter was getting sicker and sicker. And she turned to us and said, I need to go to a residential treatment program. And we agreed. She had severe OCD.
And how old was she at this time?
She was 15. And it turns out for adolescents, there were only 36 beds available at the time for in treatment, which speaks to just like the lack
it's
of
impossible.
Yeah.
It's one of the toughest parts of my job is helping people find intensive or even intensive outpatient. It's just, it's very hard.
It's too hard. And so anyway, bed came up and we were like, oh my gosh, this is amazing. And her intake date was March 17th of 2020. And I was supposed to leave for Australia March 19th. And we all know what happened, like basically March 13th. So anyway, we were worried that our daughter wouldn't get into this program. The guys in Australia started calling me and they're like, you're not going to be allowed in the country. So, and in fact, we may not get out to sea to do this pilot project. So we, like my husband, my daughter and I bubbled up here and I live in Texas. We started driving to Wisconsin, and in Australia, the guys doing this cloud brightening project bubbled up in near Sydney, and they started driving north to the Great Barrier Reef. And we were driving the same pathway at the same time, like trying to like solve these like foundational problems.
Oh, COVID.
Oh, COVID. Anyway, it was in that moment that I realized, like, I think that my daughter's story is going to be part of this book. And so anyway, the residential program saved her life. I don't know. There's no other way to say it. They taught her these exposure response prevention skills, which are amazing and really hard. And she performs them to this day. But she's like finishing her freshman year of college, and she has really great roommates, and she's super happy. And my husband and I are like maybe a little too social, but like, but it's like, but it's, she's going to have to fight it forever, but she knows how to do it now. And I think that we are going to have to fight our worst impulses around this energy transition for a long time, but we can get there. And so that's kind of one of the rays of hope. And the other one is that after my book came out, this guy from Honduras contacted me, and he's like, hey, I read your book, and in fact, I really resonated with your daughter's story in the book, and I'm reaching out to you because I'm the manager of this marine protected area in Honduras, and it's the coral are crazy healthy. And I was like, but you're in the Caribbean, and the Caribbean's hit like harder than the the Pacific. And he's like, no, it's amazing. You have to come see it. And I was like, you can't be. And he's, let me send you some pictures. So he sends me these pictures that look like the Caribbean in the 1970s. And I was like, what is going on? So my husband and I went down there, and this place should not be healthy. It is literally where the Banana Republic started. So the banana plantations were planted there in the 1910s. And all of this runoff from fertilizer has been going into this bay for 100 years. And like I said, corals evolved to live in low nutrient water. So this place is not low nutrient. And it's warm because it's a bay. And there's runoff from this river, which adds sediments to the water, which corals usually don't like sediments very much. Like there's all kinds of problems with this place. And I put my head underwater and it was like the Red Sea all those years ago. We're like, what is going on here? Like the coral cover in the Caribbean is around 12%, which means like if you have, 100 square feet, 12% of it will be covered in coral these days. It used to be 50% before we started having all of these problems. This place is like 70%. And it's got like a dozen species of critically endangered species of coral there. And like massive stands of these coral that used to be foundational, like all over Florida. And they are just as far as the eye can see in this bay. It's
How?
I
Like,
so it's right. So the place, like the thing is, it has received almost no scientific study because no one thought there would be coral there. And it was only really discovered about 10 years ago when this guy who reached out to me, he and his wife just on a whim went diving there. And and we don't know why these corals are so healthy. We do know that most diseases that are like rampant throughout the Caribbean are not in this bay. And that includes this there's a spiny sea urchin that seems to be really critical for coral health in the Caribbean. It's called diadema. It went under it had a huge die off in the 1980s. It had a huge die off about 2 years ago. There's never been diadema disease in this bay. So there's something weird happening here and we don't understand it. But it gives me all this hope because if you think about it, if this place started being polluted and messed up a century ago, could these corals be corals that learned how to handle the crap we're throwing at the ocean now? Like, is this 100 years of resilience? And it's just that this place started to get polluted 100 years ago. And so the corals have already gone through their die off, and what we're seeing are the ones who know how to handle it now. And so I will just kind of say I've been back. It's been like almost 2 years. I've been back 4 times to this place in Honduras. And then over the summer, I set up a nonprofit to try to get some scientific attention to this really special and reef that's received no scientific study.
so
And
tell me more about that in the amount of time that we have left. I know we haven't been able to talk about jellyfish. We
that's
may
okay.
have to just have you back to do like a whole jellyfish hour. But let's talk a little bit about telecoral because I want to hear about this nonprofit and about some of the work that you're doing there.
Yeah, so it's called Telecoral, and the website is telecoral.org. So TELA, that's the bay.
Okay.
And it's just so it's such a cool place, right? Like there's probably 40 species of coral, which is a lot for the Caribbean. And like I said, a dozen of them are critically endangered. There's this one species of coral called elkhorn that used to be like the backbone of all Caribbean reefs, or I don't know if that's the right way to say it. The spine maybe is a better, well,
Okay.
backbone and spine mean the
Yeah,
same.
same.
So, like the tops, all of the tops of the Caribbean reefs had this elkhorn coral, and it's a branching coral. It was huge, like groves of it grew everywhere, and it has died off and died off and died off, and now in Florida, it's basically extinct. There's you can count the number of colonies. You can count them on your hands. And in Tella, there's this whole section of the reef where it is so rich in this coral. I mean, people from Florida who see it feel like they can't believe it still exists. And so one of the things we're trying to do is create a gene bank for those elkhorn coral because they are really healthy right now. It's like swimming with white rhinos when you swim with them. You feel like this is the last of their kind, but they're so healthy there. But I am worried. And the guy Antal, who is the head of the Marine Protected Area, Antal Borgsak, who was the guy who reached out to me initially, we do feel like, what if something happens? Like, what if something happens to the last herd of white rhinos? Shouldn't we at least be protecting their genetics? So we're kind of running an emergency campaign to build a gene bank there in Tella to get at least the genetics of these endangered species safe, to keep them safe. And we're going to start with elkhorn because it's just so critically endangered, especially in Florida, especially after last summer's heat wave. But also there's another dozen species we would want to protect once we can expand the gene bank.
Oh, very cool.
Yeah. Yeah.
And so how's it been going? Like how is, the nonprofit space is tough. So how has it been for you?
I mean, am I allowed to fundraise on the show?
Of course, yes. Use me as your platform.
Yes, if you would like to contribute, like we're right now trying to raise, it's not a ton, but it's some money, $48,000 to build up this gene bank. We've identified the land. We want to pay local aquarists to care for these corals. You keep them alive in like super secure tanks. We've raised enough. Well, we've located a piece of property to put it on. We've raised enough to break ground and build duplicate gene banks. But we still need more to pay the aquarists and to build out even more gene banks and to make these as secure as we want them to be. So we've raised some money, but we still need more.
For sure. And so where can people go if they want to contribute?
Yeah, telecoral.org. It's right on the front page of our website, the kind of urgent fundraiser that we're running right now to get this gene bank. And we really want to do it before this fall. Well, August, September is when the water is the hottest. That's when, I don't know if you remember, like it's 101 degrees in Florida.
Yeah, and everything's dying. Yeah, I definitely remember that.
Yeah, so we want to build the gene bank and have the corals out of the water before that heat wave comes this end of summer.
Good. Yeah. Okay.
And it is a 501c3, so your contributions are tax deductible.
Oh, great. Okay. 501c3, you can get that. You can send that to your accountant and deduct that from your taxes. Telecoral.org. Let me just make a quick note for my editor.
Okay.
RemoveMeSaying.com. Remove me saying to remove me saying.com. Okay. Perfect. All right. Well, on that note, Juli, I just want to thank you so much for taking time with us today, for teaching us so much about corals. Of course, there's so much more to learn. There's so much in the book, not just the very personal story, which I think will touch the kind of hearts and minds of so many people, because of course we've all had either our own experience with mental health and mental illness, or there's nobody on this planet who hasn't had their own struggles or who hasn't been there side by side with somebody that we love who's had a struggle. And so I think that that's going to feel very relevant and very personal, and hopefully connect us that much deeper to these issues that, like we talked about before, sometimes can feel very far away, but are much more relevant and meaningful than I think. Once we give them the time of day, I think they start to become much more personal. And so I'm really glad that you bridged that gap for us. And I have to say too, I'm sure you've heard this before, maybe you haven't, but your passion is for your for your interest area, for your science and for your writing is really infectious. Like, it's in your voice. You have a smile and an excitement in your voice that is really, really apparent. And so I'm just so glad that you shared it with us, because you can't help but hear it. It can be a very daunting topic, but listening to you talk about it makes me excited about it.
Oh, I love that. And especially for someone who feels nervous in the water. And and I just have to say thank you so much for giving me the space to have this long conversation with you. It was really a pleasure. And
absolutely. The pleasure's mine.
And I think, what you're doing is so important and powerful because, a scientist, like, we are getting to be like human and talk on this human level. I think it really matters a lot, especially in today's world where misinformation is so rampant. So this is the kind of thing that I feel like bridges those gaps.
Oh my gosh. Here. I think you and I are like 100% on the same page about that. And hopefully, the people who have been along for this ride for coming up on 10 years now are with us, too. And I know that the show has had, a bigger listenership in the past. I think it's not shrunk down to nothing. Obviously, I still have a decent listenership, but it's shrunk down to that sort of core, like, anytime you start a show, it has the sort of artificial listenership of advertising and of marketing, and then you find your core followers and your core people who like care about the message. And I think it's the show has staying power. So like the people who listen are the people who care, not the people who are there at the beginning for like the whatever, the sizzle. And I think that the folks who have stuck around, I'm just really grateful because, sorry, I'm going to go off on a quick tangent here right at the end, so bear with me. But, I've struggled sometimes because when you've done something like this for as long as I've done it, there have been times where I've reached out to like, advertising firms or different like podcast networks or things like that and been like, okay, how do I grow and how do I do this? And they're like, well, you got to have more famous people on the show, or you've got to, do this or do that. And I'm like, I'm not doing that. It's a science show. Like, I don't need celebrities on my show. Like, I interview interesting people. I interview smart people who have a point of view. And, that doesn't always correlate with like what's hot in Hollywood or whatever. Like, that's not what I'm interested in. And I think this misinformation epidemic, pandemic, whatever we want to call it, is this sort of like Hollywood, Alex Jones, Kardashian, like that's, Donald Trump. This is the problem. Like, what makes headlines and what sells and what, is good for the advertisers is not always good for just fundamental knowledge. And I think I struggle with that because it does mean that sometimes the audience is like restrained to some extent. And so I do struggle with how do we expand without, how do we make things, how do we reach more people without sort of twisting? Because I'm never going to do that. I'm always going to make sure that we keep things fundamentally interesting because they are fundamentally interesting, not because we're sort of like faking it. And I don't know. It's an open-ended question. And my hope is just that there are always going to be ebbs and flows, and that right now we're in like a bad, I don't know if I want to call this an ebb or a flow. I don't know. I guess it depends on how you define it.
Yeah.
But right now we're in a bad one, and we're going to come back. We're going to come back from it. And the way that you come back from it is that you've got people like you, people like me, people like a lot of our colleagues, who are just like holding firm. I hope that's the case. But I appreciate you saying that.
I feel like we could go on for another hour about this.
I know. I think we could. I know. But the reason, well, I bring it up because you brought it up, but the reason I bring it up is because it's all of you who are listening to the show right now that I'm truly thanking for this, because you come back every single week. You're interested in these topics as broad as they are. You contribute to the show, by the way, because I don't have many advertisers anymore because I'm not willing to like peddle, nutritional supplements, and I'm not willing to peddle like pseudoscientific things, which seem to be the things that anybody's selling anymore. And and also just there aren't that many advertisers left in the podcasting space. And so it's that NPR model where it's like, it's Patreon. You're willing to help out just to keep it going. It's just like you with the nonprofit. Like, it's people digging deep in an economy where there isn't much left about the things that they really care about. Like, God, we're really grateful for that. And so thank all of you for continuing to support knowledge and science, and continuing to combat misinformation and pseudoscience, because this is, well, it's what we got to just keep doing. And we know that in the end, this is what keeps the train on the tracks. This is what keeps technology moving forward. This is what keeps social justice moving forward. But there are dark days, but it keeps us going. And so thank you, Dr. Berwald. Everybody, the book is Life on the Rocks, Building a Future for Coral Reefs. The previous book is Spineless. I can't thank you enough. And hopefully we will have you back on the show. Let's do it. Let's make a plan to have you back and keep the conversation going.
I would love that. Yeah.
Great. Awesome. And everybody listening, thank you for coming back week after week. I'm really looking forward to the next time we all get together to talk nerdy.